All right, ladies and gentlemen, welcome to your video lesson for 2.3. This lesson is all about taking equations and kind of getting rid of the numbers and solving for particular variables. These equations are called literal equations, and it sometimes proves to be a challenge for students. So make sure that you're taking good notes when you're looking at this. Hopefully, you're using this as a reference. Um, yeah, it shouldn't be too terrible, but please go ahead and use this video to kind of bolster that understanding that you have. First of all, let's get through our warm up here today. So this is a little bit of a review from last time. So um, again, we're kind of working on this idea of developing equations from sentences. And so let's get started with that. I want my calligraphy pen here. All right, cool. So first sentence we got to interpret is half the difference, half the difference of 16 and a number is 4. So a couple of things that jump out to me. I know is means equals. I know difference means subtraction, and I know I'm taking half of something, right? So let's break down that, right? What am I taking half of? Well, I'm taking half of an operation, okay? And what we talked about in class is that if I take and multiply by an operation, that means that operation has to happen first. In this case, I'm multiplying 1/2 times an operation. So what operation has to happen first? That difference. So the first thing I'm going to write down in parentheses is the difference of something. And remember, when we use this word difference, whatever comes after that has to be in the exact order that it appears. So it's then 16 and a number. And I know that's going to be equal to 4, right? And then I'm going to go back to the beginning and say, all right, half of this difference. So the difference happens first. Then I'm going to take half of that. You could have put 0.5 there, but this will do the same thing. And this equation is now saying half the difference of 16 and n equals 4. All right, next one. These problems are not going away. Make sure that you guys can understand how to use them. There are these rectangular patio problems. So I'm going to build a rectangular patio. I want to fence it in, but I only have 76 feet of fence, right? The patio's length must be 4 less than. So I'm taking something, right? I'm going 4 less than that. What am I taking first? Twice the width. So that is 2w, and I'm going 4 less than that. So I know my length is going to be equal to twice the width minus 4. W minus 4. Okay. And then this is also 2w minus 4. Okay. It does not say anything about the width at all, right? So the width is just the width. So I'm going to save some time here and have you not watch me write down. And let's break down this problem. So my goal is to find the length and the width, right? So first of all, I know that the overall perimeter has got to be 76 feet. And I know the length is 2 times the width, but then 4 less than that, right? 4 less than twice the width. This is what that is. I know my perimeter formula is 2 times the length plus 2 times the width. Remember, really, we brought that up from saying it's length plus width, right? We simplified it into what we see here. And so then I'm just going to substitute that stuff in. So the perimeter is 76. I have 2 times that length, which is 2w minus 4, plus 2 times the width, which is just 2w. And then I'm going to distribute that 2. So 2 times 2w is 4w. And then 2 times negative 4 is negative 8. And then that 2w just carries down. I then have like terms combined. So 2w and 4w give me 6w minus 8. I'm then going to add that 8 to both sides. And when I do that, I get 84. And then I just have to divide by 6. And then I find the width is 14 feet. Now that I know that the width is 14 feet, remember the length is equal to 2 times the w minus 4, right? That means that this 14 feet must go right here. So there's my length. There I'm going to substitute that 14 in. 2 times 14 is 28. 28 minus 4 is 24. And so now my length is 24 feet. So length is 24 feet and the width is 14 feet. Okay, if you need to see that again, go back and rewind the video, go back to it. But that is probably the third example now you've seen of a problem like that. So Probably not going away. All right, what are we doing today? Like I said, we're solving equations for a variable. These are, remember what I said, were called literal equations. And what you see on the right here is an example of a literal equation, okay? There are no numbers here. So today, when we are solving equations, typically we get an answer like x equals 2 when we solve equations. We will not be getting an answer like that, okay? We will be getting x is equal to, and then a bunch of other stuff over here. Right? We're not going to get numerical answers for today's stuff. So here's what we're going to do. Here's what we're going to look at first. Okay? If I look at this equation on the left and this equation on the right, I hope that you see that there's a connection here. So for instance, like A could be like the 3, the X is the X, 8 is B, 17 is C, right? So I'm going to model how we'd solve this equation. That's something we learned at the beginning of the year. And then we're going to apply it the same way to solve that equation, and we're going to see what it looks like, okay? The big idea here is that when we solve literal equations, there is no change in process, okay? No change in process. Sometimes we can simplify and sometimes we can't. In fact, literal equations actually involve less work, and you'll see what I mean in a minute. So let's talk about solving this, right? I'm going to solve this for x. So again, we asked ourselves the question, what's happening to x? I'm multiplying by 3 and I'm adding 8. Last thing I said was add 8, so that's the first thing I'm going to do. So I subtract 8 from both sides. Draw my little line. That leaves me with 3x is equal to 9, right? So I divide by 3 on both sides. None of this is surprising because it's all stuff we've done before. We get x is equal to 3. Now we're going to see how this same type of work is going to apply to this problem over here. So I'm solving for x, right? And I have to ask myself the question, what's happening to x? Well, I'm multiplying by a and I'm adding b. So just like in the first step in this equation, I subtracted 8. That is the exact first step I'm going to do in this equation, except for it's not a number, it's a variable. So I'm going to subtract b from both sides. Now that might sound like it's weird, but it's actually easier than what we did over here. Let me show you why. The b's are going to cancel out no matter what they are. So I'm left with ax is equal to, and now this is where we have to think a little bit. If I'm taking C and subtracting B, I don't get another letter of the alphabet, right? I can't do that. And that's where it's easier. I don't have to think about what this might be. Like over here, I had to think like 17 minus 8. I had to do a little computation there. It wasn't hard, but I had to do something. This one, I don't even have to think about it. I just have to write down what it says I'm going to do. I'm going to subtract C minus B. I can't do it though, okay? And this is as simplified as I can get. All right, what's the last thing that's happening to x? I'm dividing by a. So whatever I do to one side, I got to do to the other. And I cannot pick and choose what I'm going to divide by over here. Everything gets divided by a. The a divided by a goes away. It's really just 1. So I'm left with a is equal to, and then nothing can happen here. I can't do any math here. I can only copy down the expression, which is c minus b divided by a. And now both of these answers are correct. All right? And we did the same exact process. Only this side I can simplify. This side I can't. Right? It's the best I can do. And that's kind of what our literal equations are going to be like. Okay? We're going to apply the same exact equation solving process to our equations. Sometimes we'll be able to simplify a little bit. Sometimes we won't. All right. So let's look at another example here. This is a Fahrenheit problem. We're not going to do this whole thing just because I don't think you need to watch me do it. But I kind of have the problem out here. So the following formula is used to convert Celsius temperatures into Fahrenheit temperatures. Right now, we use Fahrenheit, right? So and this is the formula for it. So we take our Celsius temperature and we multiply by 9/5. And when we're done with that, we add 32 degrees and we get our Fahrenheit temperature. That's our conversion, okay? So to convert the following Fahrenheit temperatures to Celsius, show your work. So if I want to convert 68 degrees Fahrenheit to Celsius, that Fahrenheit goes right here. And then I need to solve for that, right? So I have an example here, right? So 68 is in for F, and that's equal to the 9/5 C plus 32. So you can see me then solving for C. So I'm subtracting 32 from both sides. 68 minus 32 is 36. And then that's equal to the 9/5 C. And now this is something that we haven't talked about a whole lot. If I have that 36 equals 9/5 C, right? And I have to solve for C, your instinct is to divide by 9/5, right? Because if you ask yourself what's happening to C, you say multiply by 9/5. We undo multiplication with division. But I don't divide fractions, right? I multiply by the reciprocal. And that's why you see me multiplying by 9/5. 5/9. 5/9 on the other side. Okay. So I'm multiplying both sides by 5/9. Move my little face here. You can see that. And what happens when I do that, right? So I have 9 times 9 over 5 times 5 over 9. Both of those things equal 45 over 45, which is 1, right? And so 1C is what I'm left with. And then over here, I would take 5 times 5 divided by 9, and then take that result and multiply by 36. I end up with 20. So answer is 20, right? And now doing the rest of these, you're probably already thinking to yourself, I'm glad he said that he's not going to do all those, because that would be the same process, right? And so what we're doing is kind of building a case for like, wouldn't it be easier if we just like had this whole equation say C equals instead, right? And that's the whole point of literal equations. By the way, 212 degrees, the temperature at which water boils is 100 degrees Celsius. And 32 degrees, the temperature at which water freezes, is 0 degrees Celsius. In my mind, these numbers make more sense for boiling and freezing than these numbers, but what do I know? Anyhow, so made a case that maybe it might be a good idea to solve this equation for C, or at least have something that we can use so we don't always have to do, a whole bunch of algebra in order to answer the question here, right? So let's go ahead and do that. I'm going to rewrite the formula for C, which means in the end, I'm going to get C equals, but remember, I'm not going to get C equals 5 or 6, right? I'm going to get an expression over on this side. So what's happening to C? I'm multiplying by 9/5, and then I'm adding 32. So I'm going to subtract 32 because that's the undoing of the last thing I said. When I subtract 32 from each side, the order is specific here. I had F, and I'm taking 32 from that. So it's F minus 32 is equal to that 9/5 C, right? And now I have to multiply by the reciprocal on both sides. So I'm going to multiply by 5/9 times 5/9. And then the easiest way to represent this is just say, all right, I got 5/9 times F minus 32 is now equal to C. So now I can just take my Fahrenheit temperature, substitute it right here for F, and then subtract 32, multiply by 5/9, and get 41. So let's practice that. Now 41 is going in for F. So I have 5 over 9 is equal to, and I'm substituting it right away. 41 is going, not equal to, sorry, multiply by 41 minus 32, and that's going to be equal to C. So 41 minus 32 is 9. So I have 5/9 times, I'm going to put this as a fraction, times 9 over 1 is then going to be equal to C. And you can see why I've had that as fraction, because it's going to end up multiplying out nicely. If I multiply straight, there's actually several ways you can solve it. If you multiply straight across, I get 45 over 9, which is 9. Or you could have realized, I'm sorry, not 9, 5. 45 over 9 is 5. So the Celsius temperature is 5 degrees. You could have also noticed that the 9's canceled out and left me with 5 over 1. All right, so that is how we would now use that formula. That was a lot easier than the work we were doing here. So we've just made a case for the need to rearrange equations, which is what literal equations do. All right, solve the following equations for y. Same type of examples here. I'm going to work with example A first. So notice there's an x and a y here, but that's no big deal. We still have to solve each of those equations for y. So what is the first thing I'm going to do? I'm going to identify that variable that I'm solving for, right? And so I'm going to ask myself, what's happening? Well, I'm multiplying by a negative 2/3, and I'm adding an 8x. So the first thing I'm going to do is subtract 8x. Again, I'm not doing anything different than if these were all numbers. That leaves me with negative 2/3. Y is then equal to 15 minus 8x. And now I have to multiply by the reciprocal, okay? So if I multiply by the reciprocal, that means I'm going to multiply by 3 over 2. That's negative times 3 over 2. So I'll get y is then equal to 15 minus 8x. And this whole quantity has to get multiplied by that, which is why it's in parentheses, times the negative 3 over 2. Okay, I could distribute that if I want to, but I'm not going to talk about that. I mean, it's obvious we can do that. I'm just going to leave it as this, and I would expect you to kind of do the same thing. All right, now applying it to the same type of problem here, solving for y, so identifying what I'm going to be solving for. And then again, what's happening to y? Multiplying by 4, I'm adding 2x, so I'm going to subtract 2x first. Subtracting 2x from both sides will leave me with 4y is equal to 12 minus 2x. And now solving for y is a one-step process. I divide by 4, and I get y is equal to 12 minus 2x over 4. Okay? So, again, this could be simplified, right? But you'd want to do both. And so this also could be simplified to 12 divided by 4 is 3. And then this could simplify to 1/2, so minus 1/2 x. Those are the same exact expressions, but as for our purposes, both these answers would be acceptable. All right, so now we're solving for x. Same type of problems. Let's go ahead and tackle this one. What's happening to x? I'm multiplying by 3, and then I'm subtracting y. Then I'm going to start by adding y to both sides. That leaves me with 3x is equal to m plus y. And then I'm going to divide by x. Sorry, it's divided by x. I'm going to divide by 3. Divide by 3. It's getting kind of late here. Divide by 3 on both sides. That'll leave me with just the x. So I have x is equal to m plus y over 3. Now, I have nothing to simplify here. Nothing at all. Okay? So that's as far as I can go. And again, I don't get x equals a number. I get x equals an expression. And that's okay. Solving this equation for y, go ahead and identify the variable. Same type of stuff, right? So now I'm going to subtract 4x. Again, process is what's happening to y, multiplying by 5 and adding 4x. So the first thing I'm going to undo is adding x by subtracting 4x. So I'm ending up with a 5y is equal to 40 minus 4x. Notice there the order is important because I had 40 on this side, and now I'm going to take away 4x from that. If I switched it, it would be wrong. Now to solve for y, I just have to divide by 5. And now I'll be left with y is equal to, and then I can simplify this part, right? 40 divided by 5 is 8. And then I can't simplify this part, so I'm left with negative 4x over 5, or you could also write 4/5 x. Those are not different, okay? So this is as simplified as we can get. I cannot combine these like terms. This is a literal equation with other variables. And that's okay to get an answer like that. No big deal. All right, moving right along here. This one looks like it's a lot more complicated, but it's really not. And we can solve this in just a couple of steps, actually. Okay? So let's take a look at it together. So I'm going to solve this formula for h. Again, I'm going to identify that variable. And there's a whole lot of other stuff here. Okay? But let's ask ourselves what's happening to h. It's being multiplied by 3 things at the same time. 2 and pi and r. Okay? It's all one multiplication. And then I'm adding this 2 pi r squared. This is just all one number, right? If I knew what pi was and I knew what r was, it's just one number. So it's essentially the same as saying like, I'm adding 2 or I'm adding 5, right? The reason it's important to recognize that is because I am going to take all of this away in one step, okay? So I'm going to rewrite this formula. Actually, can I get rid of this? Oh, sweet. Okay. So we're solving for h. I'm going to put this circle back around h because I'm solving for that, right? And I'm going to show you what I'm going to do. So again, what's happening to h? It's multiplied by this value, which is 2 times pi times r. And if you knew what r was, it would just be a number. Same thing with this. This is just a number that we would get if we knew what r was. If you don't know what it is, we're going to treat it like a quantity still. And so again, it's happening to h multiplied by this, and I'm adding that. So I'm going to subtract that. I'm going to subtract this quantity, and I can do that all in one step. Minus 2 pi r squared. By the way, this is the surface area formula for a cylinder, which you learn about in geometry. So again, order is important here because I subtracted. So I started with s, and I subtracted a 2, a pi, and an r squared. Okay? That left me with the 2, the pi, and the r, h. So again, we talked about like what's happening here. Well, the 2 pi and r is just all one thing. So I'm just going to divide by the 2 pi r. That will leave me with just the h, which is exactly what I'm looking for, right? So I'm going to divide this by 2 pi r. And all of this is gone. So in the end, I get, and it'll be s minus 2 pi r squared divided by 2 pi r is then equal to h. And that looks pretty complicated, but really it's not too bad. I'm going to go a step further and say that this can be simplified, and I'm just going to illustrate something here. Remember that when I have two terms in the numerator and one term in the denominator, both terms are being divided by what's in the numerator, right? So what I really have here is an s minus 2 pi r squared being divided by 2 pi r separately, right? And that's equal to h. The reason I'm doing this is because, look, that's gone, that's gone, that's gone, that's gone, and I can get rid of one of the r's, right? I can get rid of one of these r's. So really, if I go a little bit further, and this is something that I would not expect you guys to do, but this is just something I'm showing you, right? Splitting up this into two fractions helps me realize I can simplify. So I have s over 2 pi r. Everything's gone from here. R squared divided by r is really just r. That is the best answer, but this is the one I would expect you guys to be able to give me. All right, if you need to watch that again, go take a look. All right, this one, solving the formula for D. This is purely all variables, right? It's all we got. So solving for D, and I got two of them, all right? So how's this one going to work? Well, I first have to get them all on the same side of the equation. So I'm looking at this, it'd probably be easier to move this one over there because then I'm removing it from the K, right? And then all the D's are on the same side with one movement. That's what I'm going to do. Oop, my bad. So I'm going to, remember that's negative, I'm going to add DC to the other side. What that leaves me with is a dt plus dc is equal to k. And I can't simplify any of this stuff. And none of these variables are really going to go away, and there's no numbers for me to get. So it's very clear here that I'm not going to get a number, okay? So this takes a little bit of foresight, right? So I'm just going to illustrate that over here. I have D, well, let's imagine this. I have D on the outside of T plus C, right? If I look at this, my instinct should be telling me to distribute. And when I do that, I end up with dt plus dc. Well, check it out. That's what I got. So I'm actually going to work this backwards and do that in this problem. I'm going to it's called factoring out. So I'm going to take that d out. So it's going to be d on the outside, and the inside I'm going to have t plus c equals k. Now, I want to get d all by itself. What's happening to d? Right now, it's being multiplied by this TC quantity. So all I got to do is divide by that entire TC quantity on both sides. D plus C, sorry. And then those will cancel out, and I will be left with D is equal to K divided by T plus C. That's it. Again, I got no numerical answer. Everything that I've done is exactly the same that I would do for a normal equation, except for I can't simplify. And again, you notice I'm not doing any calculations, so they kind of are a little easier. All right, we got, I think, 2 more problems here, and then we're donezo. So let's get this stuff knocked out. All right, Average Joe's. I think this is a reference back to the Dodgeball movie. Yeah, Dodgeball. Average Joe's Gym recently expanded and has been gaining members. Currently, they have 126 members and are gaining 6 new members each week. So write an equation for the new members, the number of members, M, at Average Joe's Gym after W weeks. So we have originally 126 members at the gym. So 126, right? 126 members at the gym. And we are adding to that how often? 6 members every week. So let's call that W, right? That's what it says. So that's our expression. And that's going to be equal to the amount of members that we have. So now if 10 weeks go by, 10 will get substituted in for W, then we'll know how many members we have. Okay? But what if I want to figure out, right? Like, what if I have a number in mind and I want to figure out how many weeks it's going to take to get there? I might want to have this equation solved for W. That's what we're going to do. So instead of sharing the screen or sending the page here, that's what I'm going to do. I'm just going to solve this equation for W. So I have 126 plus 6W equals M. All right, I'm solving for W. What's happening to W? Well, I'm multiplying by 6 and adding 126, which means I'm going to subtract 126 from both sides, which leaves me with 6W is equal to M minus 126. Now what's happening to 6? Well, what's happening to W? It's being multiplied by 6, so I'm going to divide by 6. And everything gets divided by 6. I can't pick or choose, which leaves me with W is equal to, and then I'll move my face here, M minus 126 over 6. Now remember, there are 2 division problems here, and I can simplify this. One of them, I can't, right? It's just M divided by 6. The other one, I believe I can. So I think this is going to be 21. 126 divided by 6. Yep, it's 21. And I don't know why I wrote an addition symbol there. It's minus. M divided by 6, E minus, and then 126 divided by 6 is 21. That's your expression. So now all this person has to do is say, all right, well, if it's 126 members, how many weeks is that going to take? 126 divided by 6 minus 21. That'll give me exactly how many weeks there is. Okay? Cool. Last problem here. Mr. Curson has a bank account, and he's got $55 in it. He's adding $20 per week. Let B be the balance after W weeks. Let's write an equation for B in terms of W. What that means is that we're going to have B equals something, and it's going to be relating B to whatever W is, right? That's what it means. So B is the balance, and the balance is already $55. So the balance is $55, but what is he doing? He's adding to that $20 per week. So there's the equation for the balance. Now, if we want to see how much money he has after 5 weeks has gone by, we can go ahead and take that 5, substitute it in there, and then add 55. That's the balance. It says, when will the bank account have $175 in it? Use your equation in part A to solve this. Well, what that means is that 175 goes here. So I have 175 is equal to 5 plus 20W. So now I'm solving for W, right? I have a numerical value in here, so I'll actually get an answer, which is kind of cool. So I'm going to subtract 55. By the way, this is not a literal equation anymore because I only have one variable. That'll leave me with 120 is equal to 20W. And the last thing I'll do is divide by 20. And that'll give me W is equal to 6. So it's going to take 6 weeks to reach that amount of money, $175 in the bank account. All right, ladies and gentlemen, that is your lesson for 2.3. Make sure that you are doing your independent practice, finding it in your online textbook. Make sure that you are doing it in your packet. So you should be finding the 2.3 independent practice in your packet. Make sure that you complete it on Schoology. So do your Schoology check your work, and then upload a picture. You guys are doing a fantastic job so far this year. Keep up the hard work.